So first we are going to have the team 1. So they will present the smart string, the project. Okay, and also due to the limited time, each team will have only 30 minutes. So that will be roughly 2 hours if we successfully finish all the presentation. Please think about such a time the management also, but we are welcome any the question and they can answer. Sometimes I will limit the question, then you guys can have bring the question at the end of the presentation also. Okay, thank you. And you can start. When you're ready, you can start.
Good morning, everyone. This is team 1, senior design project. We are presenting a senior design project here, and our project partner is Shakir, Peter, and Clarence.
Yeah, so our project is called Smart Stream. We literally work very hard, as you understand. Myself, I'm Shakir Sara from Corporate Engineering. I took care of the hardware part, hardware design. Peter took care of software designs. Clarence took care of technology choice, and Vikanshu did all the testing and verification. That's still over the photographs and names. We are greatly thankful to our professors, our advisor, Professor Mian, our coordinator, Professor Lee, Professor Bajwa, Professor Mursik, Professor Gupta, and he is Sam, our friend, one of the graduate student, electrical and computer science, who actually helped us out on power design at the very last moment because we're having some power issues yesterday, and he gave us so many hours.
I don't like that picture.
So, Clarence.
So here's the outline. Throughout this presentation, this is what we'll be talking about. Our project goals, project research, design decisions, how do we come about making the final prototype, what it looks like right now, the hardware design, the software design, which Peter will elaborate more into. We have the testing phase, which we have 3 phases, and we'll also cover the constraints, what we've encountered throughout the year as far as issues, and also conclusions. So what inspired us to build this product? So basically, we at first we didn't have any idea what we wanted to do for senior project. So we sat together and we brainstormed and we said, okay, maybe we should definitely come up with a device that would use the RFID technology. And what it does, we have tags, and it reads the tags, and then you would have a small device, like a watch, basically, and then it would send signal to the user saying whether or not you're leaving something behind once leaving the field. So that's what we did. And also we know that so many years children have died from being left unattended or unassisted in vehicle. So that's one of the motives behind this project. So here's the goals. We wanted to have a project that would read long distance, far range. Also constant reading between the tags and the device. We wanted to be able to display contents on a small LCD screen, and also having a good power consumption, which we use a small battery, a 3.7 volt battery, and also we have some versatility. We have the user configuration, which Peter took care of, and audible alert. We use a small little buzzer that would tell the user, okay, something is being left behind, so you need to check your wallet or whatever item or object is attached to that tag. And then an on and off toggle switch. So we've done some research, and my main responsibility was to come up with better ideas as far as what kind of technology should we use for this project. We came to the conclusion that RFID would be the best option because it allows us to use RFID tags for better reading and writing. Also, it allows us to use a small battery. Considering the time that we have, and space also was, we didn't want to compromise our space as far as what we're doing. So a small battery would suit the purpose. And that's why we decided RFID technology would be the best option for this project. Also, here are the components listed below. We use the microcontroller, an LCD screen. We use the buzzer and also the battery. So our project, we wanted to have something rigid and yet very cost friendly. And by using this, we've searched the web. We said, okay, RFID, again, it plays a big role, and it sits on our advantage because we had a very low budget and we had to make do with what we got from the school, and therefore we used the RFID technology, which is passive tagged, low energy consumption, and also close range. Right now we're using the over 900 kilohertz for megahertz. I'm sorry, 900 megahertz for range. And I think that also was a big issue because we ended up using a larger, bigger antenna. And the bigger the antenna, the lesser of a range we get. Choosing our components, again, we were thinking of cost. Everything we do, we wanted to do everything cost friendly. And that's why we chose those components that we used for this project. And also easy interface.
So that's our hardware design. We have right here, that's the main RFID IC, the very top one. That's the breakout board for it because as you can see, it has a PCIe slot, which is actually gets into the CPU of the computer. So it's not really that user friendly. So we need that interface to make it workable for the pins. So that's why we connected that to the breakout board. That's the battery charger. This is the main heart of the project, the controller. That's buzzer, LCD here, and a battery here. So basically, the arrows indicates the two-way communications. This is a one-way communication. Sends the signal here, sends the signal there, receive signal from there, battery goes in there, and that's how whole functionality works. That's our first prototype that we successfully managed to do. So here buzzer is not there and battery is not there for now because we are just doing the prototype testing. So that's the breakout board. The RFID IC is right in there. Microcontroller is Arduino Fio V3 and the LCD, and it shows here sensing tags. So that's a successful test. So as this is just a description of the whole diagram, I explain the Supernova is connected to Arduino via I2C interface. That was the biggest challenge we had as far as the coding is concerned, because Supernova is basically by default supposed to work with a serial interface, and it turned out that it did not work, and we were a lot of frustrated because it was not working the way it was supposed to work. And we are really proud to say that we made it to work through I2C interface, which in fact the manufacturer themselves don't have that capability for now, because they're offering a serial interface, they're not offering I2C interface. And we did the complete coding right top to bottom ourselves, step by step, and that was really awesome. So it is communicating with the microcontroller through the I2C interface. LCD is connected via serial interface to the Arduino because Arduino is the main heart. It's controlling everything. Buzzer is hooked up with the digital pin. It's just digital high, digital low. And LCD is just capturing the display results from Arduino if the tags are in range or out of them. And buzzer will generate the alarm whenever the tag is missing. I'll hand it over to Peter now.
So this is something design. This is a screenshot from our code. This is a snippet of the code that is the communication between the Arduino, the microcontroller, and the Skytech Nova, the RFID reader. And so it's I2C communication, which is a communication protocol that supports many different masters and many different slaves. And so with this code, it's transmission to the RFID reader, which is on address 11111 or 127, all but the last bits. And I send this bytes. This is Skytech's proprietary communication protocol. They call it Skytech Protocol version 3. And so this is a code, this is a message that I pulled from their sample files. And so, you look at the code that I have there in commented, I have the message broken down. First there's a start bits, 02. Then there is message length and flags and so on. And then next, this is the code parsing the response to the RFID reader, where there's, again, the response code there, the sample code commented, and then my code is able to parse the information and retrieve the TID from the response. And then once I have the TID, I'm able to, I check if the tag is missing. Whenever a tag is read, it updates its profile with the time it was last seen, and then it compares that to the current time, and if the tag is missing for a certain amount of time, hasn't been read, and then it alerts the microcontroller, which then sounds the buzzer and displays the message in the LCD. So for testing, so this is what we're trying to do. We want to make sure that the tags will be successfully read. We want to make sure that the LCD works, that when there is an alert, when something is missing, they'll successfully be able to display that, and also make sure our buzzer is working, so there's an audio cue as well to the alarm, and that we could easily turn the device on and off with a power switch. So the first phase of testing, we were using different components. We had a TI evaluation model. I don't quite remember the exact model of the board, but it works. But the RFID range is very short and only read the tag, so we placed the tag directly over the antenna, and we had a lot of trouble working with it, and it wasn't working that well. And so the tags were being able to read, but the results were very unsatisfactory, and so we started looking for better components. So in phase 2, the main problem here was trying to communicate with the Skytech Nova, the RFID reader. And so we spent quite a lot of time connecting the reader to the microcontroller and using different communication types. We tried serial, we tried SPI, and finally we tried I2C. It worked. I can't quite say exactly why serial and SPI didn't work, but whenever we tried using that communication, then there's just no communication. But finally we were able to use I2C and it works fine. Then in the third phase of the testing, we tested the complete system. Fubashu assembled everything together, and then we loaded the code in, and everything was working fine. The only problem is that we had power issues. It only worked when we were providing power from 2 different USB ports. 5-volt power, because our components need 5-volt power, and so we wanted to create its own self-sustained system, and so we wanted to make a battery that can run the system, and so we had attempted several solutions. We talked to different professors, such as Bajwa, such as Mersic, and asked them to help us design circuits to power the systems. We considered using a 9-volt battery and using resistors to pull the voltage down to power the components, and all sorts of different things like this. Also, this is where our friend Sam came in. He really helped us here. He tried connecting several AAA batteries to give us the voltage we needed, and several other things. And he finally was able to get it to work with the 3.7-volt battery we got, which I'm not exactly sure why it works, but it works.
If I can jump in here.
Yes,
So basically, the idea was when we picked the battery, it was a 3.7-volt battery. It was providing enough power and enough current to support the whole design. And we were just supposed to do parallel communication. Professor Gupta knows about that. So that's what the idea was. And in electrical, I mean, we know when we split parallel, if we do a parallel design, the voltage doesn't drop actually. What drops is the current. And what we had in our mind is that if we put the parallel connections, it will give enough voltage to all the devices, and whichever device needs how much current, it will pull that current automatically. Because we needed like something about 650 milliamps for the whole complete system, and the battery supports that at instantaneous. So that was the easy design actually, ideally, and it was supposed to work, but initially it did not work, and it gave us a lot of hassle since last 1 week. And especially yesterday, 3 to 4 hours just troubleshooting. So that's why we had to call Sam in just to help us out, just for troubleshooting, because the idea was working, but I mean, ideally it was working, but on the testing phase, it was practically it was failing actually. Then Sam came in, and then we did some series battery connections, the AAA batteries, to convert it to 4.5 or 6 volts, but nothing worked, and eventually we ended up working with the ideal theory, parallel connections, easy ones, but that took us like 3 to 4 hours. Yeah.
Then constraints. So our range is less than anticipated. We will hope to get some 10-meter range, but it's in reality with the antenna we have is only about 2 feet, about this long. Any much farther than this, and the product start not being read. Our final product isn't complete. The prototype is working. The idea is sound, but there's some additional features I wanted to implement in the code, the software, that I wasn't, because I have trouble with the SkyTech protocol. I had trouble creating my own messages that I want to send to the RFID reader, and also time limitation. If we had more time, then the rest of this would have easily been completed, but we ran short on time, and so things are not as well done as they could have been. Conclusion is work off early, often intelligently. If we put the work in earlier, we would be in better shape than we are now. We'll happily admit that. A corollary to that is plan ahead. If we planned ahead, we would manage the time better, and the product would be better than it is now. And again, the critical path of the project, we were held up at certain points where we ordered new components and waiting for them to arrive, and then we could have managed the time better. And also, if we could test, if we could start testing the components earlier than we realized, like in the phase 1, we had those components we decided we didn't want to use. So if we were able to test those earlier, then we would have gotten more time to work on everything else. And also buy spares. We had a scare last night where we were assembling the final product, and then one of the wires on the battery got pulled out, and we got really scared. We had to resolder everything, and it was very, very scary. And so that would have been avoided if we had another battery.
So actually, the battery connector was very sensitive, delicate actually, and we just literally had a half mm of cable coming out from the battery, and it was a very critical shorting and clearance, and we somehow fortunately managed it. Otherwise, we were actually assembling the unit, and the cable broke, which is expected actually, but it was a very critical thing. But fortunately, we managed to solder it nicely, and now it's in a working condition again.
Okay. So, any questions? Should we
Yeah, we can
This is our product.
This is our smart string.
Yeah, it's a bit clunky right now. That's just a prototype. Just wanted to show to you that the concept works. It works fine. The only thing is we wouldn't have the proper casing and the wrapper and whatnot. So since we're engineers, we had to improvise in the situation. So that's what we came up with, and you can see there's a big antenna, and the LCD showing, and then all the contents are inside actually. And we use the Velcro just so we could the user could wrap it around there.
So basically, right now, we have a power switch here, as you can see. So it will turn on the device, and so there it is, and the LCD will light up, and
it'll start tracking
immediately
these
it will start
RFID tags.
looking for the tags.
And then when one of these tags goes far away,
After a few
And
seconds.
after
it'll,
5 seconds, a 5-second delay or so. Is it buzzing? No, okay. Now it starts buzzing. It's a little quiet because the buzzer is inside the mass of wires and tape, but it's
I
buzzing.
hope you can hear that.
Yeah, and
Okay.
it's showing us.
And then
So-
when the tag
Please
comes
listen.
back, it
So-
stops buzzing.
So this is reading all the 3 tags at the same time. So we can use one of the tag, let's say for our wallet, one for our phone, the one for the keys. So these tags, so I mean we just did not take it out. This is actually
A sticker.
a sticker, so you can stick it anywhere. And for now, as Peter was mentioning, on the software side, it is able to write the tag also back in the memory, so we couldn't complete that function because as I was saying, that's a protocol communication issue. So that was another plan, that it will read and write both. So for now it is just reading, but we can easily fix the writing problem also. And even if you see as the size is a little big, initially we had the plan to do like only 3 inches by 3 inches. It is doable for now. Like let's say we have another 2 weeks, we can still do the same model working with 3 inches by 3 inches with the same design. But we wanted to make it work, so we took easy approach at end of the day, just to show our idea works, and that's where it is.
Any questions? Yes.
I apologize, I'm late, but I was just curious, what are you using it for? Finding wallets?
The
and then
tracking things. If you leave
Yeah.
something behind, and then it'll alert you. So if you forget your wallets or your keys on the table, you walk out the room and then it'll start buzzing. You go, oh, I'm missing my keys. You go back and get your keys. Or a big reason we're doing this project is because a lot of parents, or it's becoming more common that parents are forgetting their children in their cars, that are buckled into their car
That's
seats.
sad. And
Right.
we will
And-
become more
and-
technology
yeah.
dependent.
And so this technology can help with that, where if you're bringing your small baby out on some errands and you attach tags to them to their clothes or whatever, and so if they wander out of your range, or if you put them down somewhere and you're absent-minded, you forget about them, then they'll start buzzing and it'll let you know that your child is wandering away or is missing.
And the range of this device, ideally it should work with 10-meter range. It gives like pretty good of 3-meter range, but the issue is the power. So the more power we give it, it can read better range. Secondly, these tags are passive. It's just passive element. There is no, it's not active. So if we can use the active elements, then it will also again increase the length. So that helps reading the range. So we were looking like at least 5-meter of range. So it will not alert the user until it is out of the range in about beyond 5 meters.
What do you mean by active and passive?
So the elements, this doesn't have a power source.
Okay.
So it just gets the power source from, it just responds to the signals from the read. If it is active, it has a power source, so it can increase the communication range. Yeah. So that basically the idea was, and that's very easy. It's not that difficult to get, because there are readily available tags. These are passive. We can also buy the active tags, but this came with the
The reader we bought.
the sample reader we bought, the evaluation kit. So we didn't try to go for active ones.
Are
Yeah.
active tags safe for live things like you were mentioning a baby or a pet?
Yes, it is safe. There is no danger because it has very small power and current, so it's not danger to anybody's life. Yeah. And actually, recently, I think the government is also passing
Requirements for
requirements
baby seats.
baby seats, because recently we had many accidents. Over 200 children died last year, I believe, from the news. That's what we heard. So that's why they're passing the requirements that it should be made compulsory that if the baby, wherever the baby seat is with the belt, the safety belt, there should be a sensor, something exactly working, doing what we are trying to do. So it is, we will see soon these kind of things in market.
Is there, if there's a barrier between, if the RFID is enclosed in some sort of
It works.
foil, will it still work?
It works because it's a radio frequency, so it penetrates.
Okay.
Yeah, but the only thing is, as I said, it's a power issue. If you have enough power, then it will penetrate. Otherwise, because radio frequency always penetrates the blocks, as we know, right? So it does. I tested it. If I put it out at my back, it does work. But then again, the problem is the power, because it needs more power. So hopefully, like we have the active text, then it will do the work. And it's 360 degree. It doesn't matter you put here, there, or there. It will read all the sides. And we have 904 or 908 megahertz frequency for now. That's high frequency. But if we get ultra high frequencies, that also again increases the range and reduces the size, as well as the size of the antenna. According to what we have learned from Professor Baj, antenna designs, inbuilt antenna designs are very difficult. So, and that all goes towards electrical engineering. So we didn't really put our head much into electrical engineering because we are on computer side. So we just opted the off-the-shelf equipment components. Any further questions?
Any other question? I have a quick question. So, is there any possibility or way to make your product as an accessory of the kind of iWatch or the something wearable device?
Yeah,
Yes,
I can
if
touch
we-
on that real quick. The only problem was time, and we actually said that if we had enough time, that we would work with a company to have everything PCB design. And unfortunately, we didn't have enough time to do this, but it can come into a small launch.
We can accommodate that. I think for that we would need to, just for the compatibility issue purpose, we can use the Bluetooth technology instead of RFID, which will again increase stronger range. Not very big range, but yes, if you want to accommodate with Apple apps or something like that, then the Bluetooth technology will be the pick. Because every phone has the Bluetooth in it. So if our technology works with Bluetooth, then it's easy to pairing, and we can also make an app on mobile app to support that.
Any further question from student? Okay, thanks so much.
Thank you.